Welcome to EC&M Asks. I'm Randy Barnett. A couple of just quick questions and answers then. And today the topic is on motors and specifically sizing the conductors for motors and the overcurrent protection and the overloads. So we're going to jump into Article 430 is where we're going to really find the bulk of our information and the general rules. The first part, and somebody just asked a general question about how do I size all of this stuff for motors? It's confusing, and it can be. Number one is don't use a nameplate on the motor. Now, that's a general rule. There are exceptions to that if maybe we're doing a motor-operated valve or whatever. But if we want to determine how much current that motor can carry, 430.6, let me find it here, 430.6A1 says, other than for motors built for low speeds, less than 1200 RPM or high torques, or for multi-speed motors, it says go to the tables. So for example, if I have a motor nameplate, say a 75 horsepower motor, I don't know, maybe on a nameplate it says full load amps, 92 amps. Great. So the full load amps is 92 amps. Next thing I have to do, I'm going to have to size my conductors, right? I don't size them based on 92 amps. I go back to the tables. So the tables, they're table 430.247 and 248 and so on. I have a table for DC motors. I have a table for single phase motors. I have a table for two phase motors. And I have a table for three phase motors. So if I look at the table for three phase motors, 75 horse, I said, say 460 volts. That's a 96 amp motor according to my table. Yeah, but the nameplate said it was only 92. I don't care. I'm going to use the table data. It's a 96 amp motor. So that's important when I go to my ampacity tables, 310.16, I'm going to choose those conductors based on that 96 amps, not the nameplate of 92. Now, something else to keep in mind is that a continuous duty motor. Look that information up as well in 430 as you need to. But if it's continuous duty, I have to take that 96 amps times 1.25, 125% of it. And now my conductors have to be big enough to carry that 96 times 125%. Okay? So in a nutshell, take a look at 430.6 though, but that's the general rules then for sizing my conductors for motor applications. What about fuses and circuit breakers? What the code calls short circuit and ground fault protection then? Well, it tells me right in 430.6, A1 once again, what do I use the table values for? There are three things I use the table values for. It says the ampacity of conductors, we just talked about that, the current ratings of the switches, and current ratings of branch circuit, short circuit, and ground fault protection. So I'm going to use the table data, that 96 amps in our case, rather than the nameplate value. And then I'm going to go to the table, what is it? 430.52C1. And this is important. So 430.52C1, maximum rating or setting of the motor, branch circuit, short circuit, and ground fault protection. So what's the maximum size fuse or circuit breaker I can use then? So I've determined my ampacity values based on the table requirements. Now I go to 430.52C1. And for instance, quite often we're going to use a time delay fuse, right? So for example, if I'm using a time delay fuse on a squirrel cage, other than design B energy efficient motor, so forth, it says that dual element time delay fuse will be rated at a maximum of 175% according to my table. That's 175% of the table value then, that 96 amps, all righty? And then finally, overloads. What about overloads? How do I set my overloads for a motor then? Well, remember, two different scenarios, right? Short circuits and ground faults. I can have a large amount of current flow in a very short period of time, and I need to de-energize that circuit quickly. So we just went through those, an overview of those rules. Now, an overload condition is where my motor starts to draw a little bit more current than what it's rated for. Let's say I have a hydraulic pump, and I've got to pump some hydraulic oil. It's a cold morning. My storage tank is outside. and that oil is cold, so it's kind of thick, and it's hard to pump it. So until I can circulate it and get it warmed up, I might overload my motor. I'd be okay. There's something built into a motor, or not all motors, but look on the nameplate. If it has a service factor rating, it would be 1.15, 1.25, whatever. That's the amount of overload. As long as I don't exceed any temperature limitations on that motor, I can go ahead and draw that excessive current into that motor, and as I heat that oil up. So service factor, and that would be an overload condition, wouldn't I? Where I'm starting to draw more current than what the motor is rated for. So if I take a look in part 3, which is on overload protection of motors in 430, and for instance, it tells me for a separate overload device, motors marked with a service factor 1.15 or greater, I take 125% of what? Not the table anymore. If I went back to 430.16, it says for overloads, use the nameplate value. So now on, say, our 75 horse motor we were talking about, I would use the 92 amps, 125% of 92 amps. Right? So take a look at that table. That's in 430.31 B1, separate overload devices. But part 3 in Article 430 is where you'll find that information. So anyway, that's all we got time for today. Some quick Q&As in. Hope you got a little bit out of it.